Okay, in this video, I'm going to look at a third application of logarithmic functions. It's what we call the decibel scale. So it's another scale. The decibel scale is a way to measure the sound level or how loud a sound is. So the decibel scale is a number. So for a sound, we'll call that beta. And the way you get beta is using this logarithmic equation. So 10 times the log of I over I naught, where I is the intensity of that sound and I naught is what they've defined as the base intensity. This is similar to kind of the intensity of a Richter scale measurement. Won't get too much into how you measure sound intensity, but basically it's measuring kind of the vibrations caused by that sound. So the louder it is, the more intense or the more vibrations that sound would cause. Um, I naught is kind of the base intensity, so like that would be a sound that you can barely hear, or not even really hear, like just sort of right at the threshold of being able to hear it. So if I naught was your I value, you would get a decibel reading of 0. Anything bigger than I naught, you're going to get a decibel reading bigger than 0. Okay, so now we saw this with the Richter scale example. So if you want to compare two sound levels, say beta 1 and beta 2, then you can just use this equation. You don't have to use that original equation with I naught. The difference between two sound levels will be equal to 10 times log. Let's so I need 10. I need a 10 in here because it's different than the Richter scale one. So it would be 10 times the log of I2 over I1. Okay, so let's look at an example to see how we can use this equation. Okay, so here's an example. So hearing damage can occur at anything greater than 85 decibels. So this dB, that means decibel. That's the units that we use for decibel scale. So 85 would be kind of the threshold for hearing damage. Sound levels at a concert, music concert, can reach as high as 140 decibels, probably depending how close you are to the speakers. How many times as intense is a concert than the threshold for hearing damage? So if you look at the decibel rating, it's not quite twice as big. So the decibel reading is not quite double, but we're going to see the intensity of that sound is actually far, far greater than double. So let's say let beta 1 be the threshold for hearing damage, and beta 2 be the concert decibel reading. Okay, so remember we have that equation, beta 2 minus beta 1 is equal to 10 times the log of I2 over I1. Now this value here, I2 over I1, is what we're looking for. So we want I2 over I1 because that will tell us how many times intense I2 is compared to I1, which I2 would be the intensity of the second sound compared to the intensity of the first sound. So beta 2, that's 140, minus beta 1, that's 85, equals 10 times the log of I2 over I1. 140 minus 85 would be 55, equals 10 times the log of I2 over I1. Divide both sides by 10. You get 5.5 on the left. These 10s divide out. And you've got log of I2 over I1. So now this is just a logarithmic equation. Remember, it's base 10. So that would be 10 to to the power of 5.5, if you convert to exponential form, equals I2 over I1. And 10 to the power of 5.5 is a rather large number. That's 316,227. So that intensity of that of that concert compared to what would cause hearing damage, so the vibrations, um, the sound intensity is over 300,000 times more intense than what you should be listening to. So therefore, the sound level at the concert is 316,227 times as intense as the threshold for hearing damage. Just put that was approximately, I did round that decimal off.